The exact origins of the cotton plant are still unknown, although archaeologists have unearthed pieces of cotton cloth dated nearly 8,000 years old. The cultivation of cotton can be dated back to 3000 BCE to the Indus Valley Civilization in India. Cotton was also cultivated in ancient Egypt and China around 2000 BCE. On the other side of the world, cotton was also growing in Mexico and Peru. Cotton cultivation had been going on for thousands of years. Cotton was introduced to Europe by Arab merchants around the year 800, and by the year 1100, the people of West Africa were growing and weaving cotton cloth. In 1492, Christopher Columbus discovered cotton growing in the Bahamas, and cotton was first planted in Florida and later in Virginia between 1560 and 1607. A cotton gin saw is a high-carbon circular metal saw blade with a serrated edge where a very specialized tooth profile is used. These saws are mounted and spaced evenly on a horizontal rotating mandrel driven by a motor. This apparatus is referred to as a saw cylinder. The saw cylinder is an essential part of the cotton gin. The saw blades are introduced to seed cotton from the seed roll, which is held in the part of a gin stand called a roll box. These specialized saw blades were created to not cut the cotton fibers, but to only snag the fibers long enough to pull them between fixed metal bars, known as ribs. These ribs are spaced just enough to easily allow the lint to pass through, but are too narrow to allow the cotton seeds to pass. This is the point of lint and seed separation, which is the key required action for any cotton gin. The cotton lint is removed off the backside of the blade's rotation by use of a brush and air, and will continue along to additional cleaning before it is prepared for its baling process. While the seeds, now separated from their lint, will travel down the length of the rib, eventually falling out from the bottom of the gin stand into a conveyor, which leads to a seed storage area. Although it sounds simple enough, there are a lot of conditions that have to be met before this process will work properly. Let's learn more about the history of the gin saw and what makes it such a complex product to make, and why it's deemed the most important deciding factor of the overall cotton ginning process.
A new industrial revolution had started towards the end of the 18th century, shortly after the Revolutionary War. Textile processing improvements significantly was boosting the world's need for raw cotton, and in America, we were in great need of trading partners. So the stage was set for Eli Whitney's invention and patenting of the spike-tooth cotton gin in 1794, and then 14 months later, with Hodgin Holmes's patent, his concept of a sawtooth cotton gin in 1796. Throughout the centuries, many methods had been used in finding a better way to separate the seeds from the cotton lint. And regardless of who originated the basic principle of the saw gin, it is Holmes's basic patented design of a continuous flow gin, utilizing toothed saw blades that dominated the ginning industry as the American cotton industry grew. The new cotton gins were creating a dramatic increase in the production of cotton. Upland cotton started dominating cotton production and became the primary cotton grown. The cotton gin also inadvertently played a major role in the expansion of slavery in the United States, since more and more acreage of land was being dedicated to the growing of cotton, and additional labor was and would be required. Gin saws have continued to evolve over the years, and they have become increasingly sophisticated, operating through some of the harshest conditions and at speeds well above any known in the history of cotton ginning. But in some ways, they have always been the superstar of the ginning process, and how some things just never change because they are just what is needed to get the job done. Here is a quote made in 1898 about the description of a perfect cotton gin saw blade of the time.
The method of making gin saw blades is substantial, which comprises many steps of preparing an accurately flat and smoothly polished annular blank, of uniform accurately predetermined thickness, homogeneous composition, free from surface scale and of fine and dense crystalline structure, must be substantially devoid of internal strains while shaping the outer edge of the blade to form teeth, and filing said teeth to pyramidal shape, thereby producing a stiff blade of standard and predetermined thickness whose body and teeth are of uniform texture, the teeth being tough and capable of taking and retaining a fine edge.
The manufacturing process for cotton gin saw blades is a complex process that involves a variety of different steps. Today's modern cotton gin saws are made of high carbon quality steel, which is stamped to a precise size, then pressed together in fixed groups. And then pressure heat treated to release all possible stresses, which might be retained in the metal. These processes ensure the blade's ultimate flatness, which is key to functioning within the gin stand. American-made steel has always been the preferred raw material used due to the strict required American quality standards. This aspect is vital in the gin saw's performance and effectiveness, since key chemicals, mechanical and metallurgic properties within the steel being used are a huge factor in the durability and long-lasting nature of a quality cotton saw blade. With the saw blade now being absolutely flat and without stress flaws, the process of forming the proprietary tooth profile begins. Although the tooth design of a saw blade varies between manufacturers, the direct point of attack angle and the precisely grounded tooth sides contribute greatly to the interaction between the saw's teeth and the cotton lint. The saw's teeth's key responsibility is to snag the lint through the ribs in the fastest manner without damaging the fibers. Without precisely formed teeth, this task could easily cause fiber damage, which would be highly frowned upon at the cotton mills, or also could cause gin fires due to high friction. To ensure consistency within all saws made, highly functional quality controls should be in place at the manufacturers. Last, but not least, the protection and proper packaging of the finished saw blades are also key to the end user's satisfaction with the received product.
We would like to thank Legacy Gin Saws for their assistance. Their knowledge and expertise were instrumental in the making of this film. Legacy Gin Saws are the leader in American-made gin saws throughout the worldwide cotton market.